Dear students, in the last module, we have discussed how a program is executed by understanding different phases and layers of program execution. That was fetching an instruction from main memory, decoding it, and then executing it. In today's module, we will have a practical example of how program from fetching until execution is performed within the computer. In your book, there is an example of a machine. Your book is basically following a machine and set of instructions that has been made, and those instructions are referred in different chapters of your book. So I want to see you your book page number 581 to see that which kind of instructions are available, what they mean, and then we will apply those instructions in our today's lecture. So let's go to the page, to the book. So I have opened the book, page 581 already for you, and it is Appendix C, and this is a machine architecture and machine language instructions that has been defined here. So an instruction in our examples will have 4 bytes. So one is the opcode. Opcode means what the instruction is trying to do, and then there would be the operand, that is something on which the operation will be performed. So for example, if you see an instruction with 1 in the start of the instruction, that means you need to load the instruction from the main memory. And RXY is representing the register number where that loading should be performed, and XY is denoting that location in the memory from where the instruction should be fetched. So for example, if it is written 1500, so this would mean that 00 is the location in the RAM and 5 is the register number available within the CPU, and 1 means that you need to load. So in today's lecture we will be using this instruction, and then we will be using 3 number instruction, that is store. So whenever you see 3 in the start, that means store. Where to store? At XY location, and what to store, that is the content that is available in the register R. And then there is a add instruction with 5 that adds 2 registers and store them in another register. So we will not be using all of these instructions in today's module. However, you can learn about such a very small set of instruction that how actually computer performs on the back end. So now we will be moving towards solving a practical problem using the Appendix C, which I have already shown you. So for example, we have something here. We have loaded a program into the RAM, and that program is available here, 156C, 166D, this one, and this one. I have grouped them together because these 4 things are forming one instruction. So this means 156C is one instruction. Then 166D is another instruction. Then 5056 is another instruction. Then 306E is another instruction, and C000 is another instruction. So actually we have these 5 instructions that are available in our RAM, and as we mentioned that there are 2 special purpose register, program counter and instruction register, and program counter has the address of first instruction, that is A0. You can see it is pointing to this first address. As soon as this instruction is fetched, so in instruction register we will have 1, 5, 6, C. As soon as this is fetched, the content of program counter will be changed from A0 to A2. We have incremented by the value of 2 because our instruction is residing on consecutive 2 locations. So the next instruction is starting from A2. So therefore, when this instruction has been executed, 156C, next time the computer should fetch the instruction 166D, and that instruction is starting from main memory address A2. So first time this instruction is executed. So let's execute it. 156C means you need to load 5 mean at the register number 5. So let's make a register number 5 here. So suppose this is a register number 5 and this is a register number 6. So 6C means in the RAM there is a address known as 6C. Whatever is available in this 6C, that should be loaded into register number 5. So suppose here we have 10. So that 10 will be loaded over here. So next time the instruction will be fetched from A2, that is 166D. So this means this instruction register now will have 166D. And what does it mean? Again, there is a starting point 1, which means load. Where to load? At register number 6. And from where to load? From the address in the main memory, that is 6D. So for example, there is another address 6D here. So suppose there is a value of 5 in 6D. So that value 5 will be loaded in the register number R6. And when we loaded this instruction, we forgot to add the program counter by 2. So this would be pointing now to A4. So next time it will be fetching instruction from A4, that is 5056. And as soon as the instruction is fetched, this program counter actually increments by 2 and pointing to A6. So 5056 means 5 is meaning that you need to add. What to add? 5, 6. So 5, 6 is the register numbers within the CPU. These are the register number 5 and 6. It is saying that add register number 5 content with the register number 6 content and store it in another register that is known as 0. So 10 plus 5, 15 will be stored at a register number 0 that is available in the CPU. So next time when this has been executed, so next instruction will be fetched from A6, that is 306E. So 3 means store. Store means you want to store some information from the register to the main memory. So what to store? The content of 0. So the content of 0 are 15. It should be stored at an address of 6E. So there is another address in the main memory known as 6E, and that will hold actually the 15 value, and the program counter is now pointing to A8. And the next instruction is C000. So this instruction means that you should stop your program. So in this example, we have fetched two numbers available in RAM at position 6E and 6D, and we have moved them to the R5 and R6 two registers, and after addition we have again stored them into the RAM. So if we conclude today's module, we have actually performed a well-known real-time example that how the program actually is executing within the computer.